Okay, geometric sequences. Now, geometric sequences are also very common, and a geometric sequence is one in which there is a common ratio, so no longer a common difference, but a common ratio between consecutive terms. The common ratio is denoted by r, so we say the ratio is r. In this example that we're given here, 2, 4, 8, 16, 32, notice that we're taking each term and multiplying it by 2 every time. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, so our common ratio in this one would be r equals 2. I'm multiplying by 2 every time. Now r could be a fraction too. R could be like 1/2, in which case we'd be dividing by 2 each time. Because division is really just multiplication, right? Or the opposite of multiplication. So r could be a decimal, r could be a whole number, r could be a fraction, r can be any number of things, as long as we're multiplying by that each time. To find r, you're going to want to write this down. R equals a sub 2 divided by a sub 1. Assuming that we know we have a geometric sequence, we can take the second term divided by the first term, and that will give me the common ratio. Okay, rule for the geometric sequence. A sub n equals the first term, a sub 1, times r, which is our common ratio, raised to the n minus 1. Very similar notation to arithmetic. A sub 1 is the first term, a sub n is the nth term, n is just, well, n, and r is the common ratio. So the nth term for a geometric sequence with first term 3 and common ratio 2 is given by what? What is the rule is the question here. So a sub n equals, well, the first term is 3 times, and I'm going to put this in parentheses. I don't really have to, but I just feel better about it when it's in parentheses. I'm less likely to make a mistake in my calculator. 3 times 2 raised to the n minus 1. Remember that n minus 1 behaves like the x in a function, okay? And that's it. There's nothing I can simplify there. Be very careful. Do not multiply that 3 and 2. It's 3 times 2 raised to the n minus 1. That's why I have parentheses around the 2, and that's kind of connected to the n minus 1. Okay, so that's how we write a rule for geometric sequence. Once again, we need two things. We need the first term and the common ratio. Alright, write a rule for the nth term of the sequence, then find a sub 7. Now we have to be careful. I put a lot of caution things on here for a couple reasons. One, this looks like we're decreasing each time. So our common ratio is probably going to be a fraction. Two, we cannot multiply a sub 1 and r when we put it into our calculator. That's going to be two kind of pitfalls we're going to have to avoid. So let's first find r. And we said r is the second term divided by the first term, if I know it's a geometric ratio, okay, or geometric sequence. So I'm going to take negative 76 divided by 152 and simplify. And I think that's actually going to be negative 1/2. I think we're cutting it in half each time. So our common ratio is negative 1/2. This takes a lot of the guesswork out of trying to write a rule for this. I notice that it's geometric. I'm cutting it in half each time. We should check to make sure negative 76 divided by 2 or multiplied by negative 1/2 gives me 38. And 38 divided by 2 is 19, and so on. And we've got that negative 1/2. It's going to give me the alternating signs. Okay, so this function, or excuse me, this sequence can be written out with the rule a sub n equals the first term, 152, times negative 1/2 raised to the n minus 1. Okay, and leave the negative 1/2 in the parentheses. All right, and that's the rule. So if you want to find the seventh term, we would just take a sub 7 equals 152 times negative 1/2 raised to the 7 minus 1, or to the 6th power, and you could go ahead and figure out what that is. I think it's actually going to be a decimal because we ran out of 2's in our sequence. But anyway, that's it for using a rule for geometric sequence. Okay, I think we got one more example. Oh, whoa, watch out. Last example here. One term in a geometric sequence is a sub 4 equals 12, and the common ratio is r. So now, I said we needed two things to write a rule for geometric sequence. We needed the first term, and we needed r. This time I've got r, but I don't have the first term. That's okay, though. I think we can still write a rule for it. Remember what my formula is. It's a sub n equals a sub 1 times r raised to the n minus 1. Okay? And here, I know that a sub 4 is 12. Okay, and I know the common ratio r is 2. If we plug all that stuff in there, I think we'll be down to one variable that I can solve for. So let's do that. Let's plug in a sub 4 equals a sub 1, I don't know that, times r. R is 2 raised to the n minus 1. Well, my n is 4, so this is going to be raised to the 4 minus 1, which is 3. Okay? So you're thinking, I have a sub 4, a sub 1, what am I going to do? I've got two variables. But remember, up here we said a sub 4 is 12. Alright, so I can plug in 12 for that, and I'll write it out this time. 12 then equals a sub 1 times 2 to the 3, I think is 8. Alright, and so if I divide both sides by 8, I get a sub 1 equals 12 over 8, which reduces to 3 over 2, or 1.5. So now I've got a sub 1, and I've got my common ratio also. So let's write the rule then. A sub n equals the first term, which is 3 over 2, times 2 raised to the n minus 1. Okay? And that's it for geometric sequences and arithmetic sequences.